Hi everyone, I'm glad to be here. Today we're going to talk about modifiers. There are different modifiers. We are going to investigate three of them and later we cover the rest. Totally we have 7 or 8 modifiers. The plan for today is talking about maximum material condition or MMC, let's say maximum material boundary or MMB. What is the symbol for MMC? M inside the circle is going to represent MMC condition. What is the meaning of MMC? MMC stands for maximum material condition. If we are going to implement MMC for pin, for sure we need to have the maximum material exist on this pin. That's why we would like to have a biggest pin. If we are going to implement the MMC for the hole, we would like to have maximum material for this part. That's why we would like to have a smallest hole. It is the concept of MMC. You may ask why we are interested to have the biggest pin and the smallest hole. Why we are going to implement this one? Yes, you are right. When we have the smallest hole and biggest pin, it is the worst case. If these two components can work for this condition, we can do the assembly. That's why we would like to implement MMC to see does these two components work for worst condition? If it works, yeah, we can do the assembly. Let's go for the first example here. We can see the pin here. The diameter of this pin can be changed in this interval, and we have modifier here with the value of 0.3. The maximum size of the pin is 9.5, and then we need to modify it. We need to add material on that part. We are going to add this value to the maximum value of the diameter of the pin. We can have 9.8. Based on the perpendicularity symbol as it is presented here, we can have this figure. In this boundary, all pins should be in this boundary. Let's go to the next slide. We have another example here. As we can see here it is a pin with the diameter of 10 plus minus 0.1, and we have the modifier with this value 0.05. We can see what is the maximum size of the pin. The maximum possible size of the pin is 10 plus 0.1, and then we need to modify that one plus this value to add more material on that. We can have this value 10.15. It's going to represent the size of the diameter of the gauge. If this part can go through this gauge with this diameter, it is acceptable part. And again, another example we have here for this pin, we are going to calculate the maximum possible diameter of the pin. It is 0.5 plus 0.0112. And then we need to modify it by this value. We are going to have the maximum material on this pin. We calculate the diameter of the hole for gauge. This diameter of the hole for gauge is going to represent the virtual condition. It means for different diameter of the pins, all of them should be in this virtual condition. We have another example here. Again, we are going to calculate the maximum possible diameter of the pin, and then we are going to modify it. We need to add it. We can calculate the virtual condition for this pin. The all possible diameter of the pin should be in these virtual boundaries or virtual condition. Now let's compare when we have the modifier and when we don't have the modifier. For this example, the diameter of the pin is going to change between 29.5 and 29.9. We don't have any modifier. It means the center of this pin can be changed in this tolerance zone. It is fixed and constant value, as we can see here. But when we are going to implement the modifier, what happens? We are going to define virtual or worst condition. For virtual condition for the pin, we are going to see what can be the maximum diameter of the pin. That's why we are going to consider the maximum value of the pin and then modify it, add it with this value. We have the 30 here. And if we are going to see what is the tolerance for this pin diameter, if it is 29.9, it is 0.1. But for other diameter of pin, we have another value of the tolerance zone. The center of that can be moved more because it is in that virtual condition. As we can see, it is not fixed. That's why we would like to call it dynamic tolerance, or we can call it bonus tolerance. When it is a small pin, it means it can move in that, the center of this pin can move in more tolerance zone. If it is big, it cannot. That is the advantage of the modifier. It is dynamic tolerance. Let's implement MMC for the hole. Here we have this yellow part and we have this diameter. The diameter of the hole can be changed in this interval, 15.1 and 15.5. And we have this modifier symbol here by this value and diameter symbol here. In order to have the maximum material condition, we need to have more material. We need to have the smallest value of the hole here, 15.1, and then we are going to modify it to have more material. We should have the more smaller value. We are going to modify it. We make minus, and then we are going to calculate this value. It's going to represent the diameter of the pin gauge. And this is a virtual condition. For all holes, we should not have any interface for this pin gauge. The same scenario is going to repeat here. Here, another example we have here, the hole should be, the size of the hole can be changed in this interval, and then we have modifier. In order to have the maximum material condition, we need to have a smallest hole, and then we need to modify it. We are going to calculate the virtual condition for this hole. The other holes should not come in this boundary. In that situation, it is acceptable. Let's compare when we have the modifier and when we don't have modifier for the hole. In this example, the hole diameter can be changed in this interval, and we don't have any modifier symbol here. It means the tolerance zone for the center of this hole is fixed and constant. It is 0.1, as we can see here. But when we are going to implement the modifier, it means we are going to define the virtual condition. When we have hole here, in order to have the maximum material, we should consider the minimum possible size of the hole and then modify it. It means the minimum is 13.1, and then we need to modify it to have more material. We make minus. This virtual condition for this hole is 30. And if we are going to compare this one, virtual condition, with the diameter of the hole, we can see the tolerance zone for the center of this hole is not fixed. It's going to change based on the diameter of the hole. Somehow they call it bonus tolerance. And now I'm going to close this session. For next session, I will talk about LMC, least material condition. I hope you enjoy from this session. Thank you for today and have a nice day.